Hi everyone, we're going to find the range, quartiles, interquartile range, and outliers for the set of data. We're also going to do a box and whiskers plot, also known as the box plot. And let's get started. So the first thing I like to do is just write these from least to greatest, the numbers. So let's give me a minute here. We got 25. Looks like the smallest number. 27. I'll erase this in a minute. What's next? 39. 39. And then we have, we had 48 in the 46. And then 48. In the 50s, we got we missed 10. So let me squeeze in 10 here. 10, 25. We got the 10. Now let's do the 50s. We have 50, two 56s. Okay. Do not know why I wrote 55. 56, 56, and then 92. All right. So let's count how many numbers we have. I'm going to go ahead and erase that back out. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. So that means we have even numbers here. Let's go ahead and do the range first. The range is the difference between your upper number, the greatest, and the least value. So the greatest is 92 minus 10. So that's going to be 82. Now let's do our quartiles. Quartile 1, quartile 2, quartile 3. Quartile 2 is just your median. So 1, 2, 3, 4, 5. And then we have 1, 2, 3, 4, 5. All right. So the number halfway between 46 and 48 is 47. Or you could take those two numbers, add them up, and divide by 2. Now you take your, for quartile 1, you're going to take your lower half of the data, which is here, and take your middle number. So that's going to be 27. And then for the quartile 3, take your upper half, and that's going to be 56. Now, for your interquartile range, that's the difference. This is this area right in here. So it's the difference between quartile 3 and quartile 1. So that's going to be 56 minus 27. And that's going to equal 29. We're going to use that number to get any outliers. So let me just write 29 here. So we know that was the interquartile range. All right, now I don't know if I want to do the box and whiskers thing here. Let me see. Let's go by tens, and we'll start with 10. So if we go by 10, I'll start here. 10, 20, 30, 40, 50, 60, 70, 80, 90. So I'm going to go ahead and leave it at 90. I know my 92 goes outside a little bit and put it right there. That way I don't have to copy it down again. And then we have 10. So those are your values, the greatest and least values of the set. Now let's do our interquartile range. So for quartile 1, we go to 27. That's about right there. 47 goes about here, and 56 is about there. The quartiles is what you'd use your box for. So you put your box in there. All right, and then draw a line for your quartile 2, which is your median, which is at 47. All right, now you're going to go ahead and take your whiskers and go to your least and greatest value of the set. So that's the whiskers part. And what's left is the outlier. So what we need, and I'm going to go ahead and erase this part real quick. We need to take 29 times 1.5. And that's the magic number we need. So 29 times 1.5. That's 43.5. So what we're looking at is the difference, this difference here from the upper, let's look at it. An outlier is any value in the set of data that is at least 1.5 interquartile ranges. That's why I multiplied it by our interquartile range. Beyond the upper, our upper is 56. This was 56. And our lower was 27 here. So what you're doing is you're taking 27 minus 10, and that gives us 17. So this difference here is 17. That is not greater than 43.5. That means 10 is not an outlier. Now let's look at this one. This one looks a little further away. So 90 minus 56 is going to be 34. So this difference is 34. And that is not greater than 43.5. So that means there's no outlier here. Means 90 is not an outlier. So no outliers for this set of data. Thank you. Have a nice day. Bye-bye.
Class, Miss Shaw's class. Boy, I love math. Miss Shaw's class, Miss Shaw's class.
Don't fail! Watch Miss Shaw's videos for free.